Hello dear students, today's lesson is about solving the first degree equations in one unknown. Let's see the meaning of our lesson. Here, in this equation x plus 2 equals 7. In the previous lesson we studied that this equation is of the first degree. Why? Because the greatest power here is x to the power 1, so this equation is of the first degree. And how many unknowns do you have here? I have only one known, which is x. In another example, I have 3y plus 4 equal 16. So the y is to the power 1, so this equation is of the first degree, and I have only one unknown, which is y, so this equation is of the first degree with only one unknown. Here in this example, x to the power 2 plus 2 equal 27. This equation is of the second degree because x is to the power 2. And here x plus 2y equals 30. This equation has two unknowns or two variables. So this is not related to our lesson today. Let's see how can we solve the equation. Solving equations means finding the value of the unknown that satisfies the equation, and this value is called the solution of the equation. Or it means to find the value of x or of the letter. Sometimes he gives you the substitution set, and easily you can find the solution set by using the substitution method as we studied in the previous lesson. But in other cases, the substitution set is too long, as n or z. He said that the substitution set is n, or find the solution set in z. And it may be impossible to use the substitution method, of course. So in this lesson, we will study an easy and simple method to find the value of x, depending on the properties of equation. So here I have x plus 2 equals 7. In this equation, x plus 2 balls equal 7 balls. So the goal in this method is to isolate the unknown or the variable alone, or the x alone, in one side of the equation, and the constant or the numbers in the other side of the equation. So I want to make the x to stand here alone and push the all constant in the other side. So here I have to cancel these two. I want to the x to stand alone, so I have to cancel these two. How can I cancel these two? By subtracting 2 from this side, and because this is an equation, I have to cancel or subtract 2 from the other side to keep the equality of the equation. So here x now is standing alone in this called the left hand side, and in the right hand side I have now 7 minus 2 equal 5. So now I have x equal 5. Okay, so the goal, we said, is to isolate the values, the unknown alone on one side, and we can do this by using the properties of the equation. What are the properties of the equation? The equation remains valid if the two sides are added to the same number or subtracted by the same number, or multiplied to the same number or divided by the same number. So the conclusion, I can say that if A, B, and C are three numbers, and I have an equality between, or an equation between A and C, that A equals C, then adding the same amount to both sides of the equation doesn't affect the equality of the equation. That if I add B to both sides, it will not affect the equality of the equation. Also, subtracting the same number B from both sides of the equation will not affect the equality of the equation. Multiplying A and C by the same number B will not affect the equality of the equation. Dividing the both sides by the same number B will not affecting the equality of the equation. So let's see an example to make it more clear. Solve the following equation in N. So I have here the substitution set is N. Okay, x plus 5 equal 25. So by using the properties of the equation, I will cancel this 5 to make the x or the variable stand alone. To cancel this 5, I have to do an subtraction to this 5. I have to subtract this 5 from this side to cancel it. So I will subtract 5 from this side, and to keep the equality of the equation, I have to subtract 5 from this side too. So I have to subtract 5 from here and subtract 5 from here. Why subtract 5? To cancel these 5s, because 5 minus 5 equals 0. So the 5 will go with this 5. Now I have x equal 25 minus 5 equal 20. And the solution set equal 20. And 20 is belong to the N, so this is the solution set. Okay? What if I use another way? What if I imagine in this exercise, I imagine that the 5 moved from the left side to the right side and became minus 5 or negative 5. I will reverse the operation. This is plus 5 will go to the other side and became minus 5. So the equation now will be transformed to x equal 25 minus 5. X equal 25 minus 5, which will be x equal 20. Okay? And then solution set equal 20. So here I just moved the 5 from this side to the other side with the opposite operation. It was plus 5, will be here in the other side minus 5. Okay, solve another example. Here 2x equal 20. Find the solution set of the following equation in Z. So I have the solution substitution set here is the Z, all the integers. So here 2x equal 20. To solve this, I will move, or I can imagine that the 2 moved from the left side to the right side and became a divide 5. Why divide 5? Because 2 here is multiplied to x. If it moved to here, it will be divided by 20. So 2x equal 20. I said that the 2 will move to the other side by dividing operation. The 2 here is multiplied to x, so we'll go here by division. And here x equal 20 divided 2, so the x equal 10. And please keep all the equals above each other and all the x's above each other. So the solution set here will be 10. And 10 belong to z, so this is the solution set. Let's solve the exercises from the booklet, page 42. Find the solution set in n. Exercise number C. X minus 9 equal negative 5. We said it's an easy way or easy method to move negative 9 or minus 9 to the other side by plus 9. Opposite operation. So here I have x equal negative 5 plus 9. And x equal negative 5 plus 9 equal 4. So the solution set will be 4. 4 belong to n, so the solution set is valid and will be 4. Another exercise, page 43. Find the solution set in z. X over 7 equal negative 5. Here I want the x to stand alone in this side. 7 here with in a relation with the x by divide, so the 7 will go to the other side by multiply. So x equal negative 5 multiplied 7. And x equal negative 5 multiplied 7 equal negative 35. So the solution set, negative 35, belong to z. So solution set can be negative 35. Exercise number 3. So here, number G, 4n minus 3 equal negative 7. I have two operations here to do. I have 4 multiplied n and minus 3. First, I will go for plus or minus. I will leave the coefficient at the end, okay? So here I will go first and transfer the minus 3 to the other side and go with positive 3 or plus 3. And now my equation is 4n as it is equal negative 7 plus 3. Here 4n equal negative 4. Now the turn of 4. 4 here by multiply will go to the other side by divide. And now n equal negative 4 over 4. So n equal, don't forget the negative, n equal negative 1. Now I want to find the solution set in n. I can see that negative 1 doesn't belong to n. N has no negative numbers. So the solution set in n equal 5. But what about in z? Yes, negative 1 belong to z. So the solution set in z equal negative 1. Here, what if I have 2x plus 5 equal x plus 9? I have here 2 in the both sides. I have x's, but it's still this equation still with one unknown, because I have only one unknown, which is x. So I have to collect all the x's in one side and move all the constant or all the numbers in the other side. So first the x will move to go to the 2x. X will go to the other side, and of course it will change the sign. It is here positive x will go to the other side by negative x. What about the 5? The 5 also will leave its place and go to the other side by minus 5. So my equation now is 2x minus x equal 9 minus 5. So here 2x minus x equal x. and 9 minus 5 equal 4. So I have now x equal 4. Keep the equals under each other. And now my solution set in n equal 4 and in z equal 4 because 4 belong to n and belong to z. The solution set equal 4. Thank you, juniors.